coordinates are interrelated to each other. So we must see what is degree of freedom. So it is actually the minimum number of independent coordinates to describe the dynamics of system. Clear? We will see many examples to clear this concept. So examples are like this. See, in this particle is moving in a straight line. So if particle is moving in a straight line, so it has only 1 degree of freedom. Means it has only one constraint. Either it move to left or to right, but it has to move in a straight line. So that's why it has one constraint, and that due to that constraint, it has 1 degree of freedom. Now suppose a particle moves in a y equal to sine x as a function. Then particle has same here one constraint. Particle either move up, down, but behave like as a sine function. So its degree of freedom is also 1. Now suppose a wire, and over that wire Bead is fixed or Bead is moving, but theta angle is fixed. Then its degree of freedom is 1. Along the wire degree of freedom is 1. And when the wire is moving like this, is moving in this way, then the degree of freedom along the wire remains same, means 1, because it has only one constraint, and due to that constraint it has degree of freedom 1. Now we have these situations. For example, a particle is moving on a spring, then it has only one constraint, that is a spring. Whatever the shape of a spring is, the particle behave in that condition. So its degree of freedom is 1. Now these two conditions also. A person running along the track. Now when we see the word along and on, these are the two different words. Along the circular path means it has constraint and it will remain fixed to that path. But when we are seeing the word on, then the circular track is like this. This is a circular track. Now it can move in this way also. This way. So it can change its position, either X or Y. But when we see along, so it's moving like this is a circular path, and it is fixed to the direction of circular path, means always circular, always circular. So that's why there's a difference. When we see the word along, the degree of freedom is 1. When we see the on, the degree of freedom is 2. Suppose the track is circular. Now, track is in the shape of a square or rectangle. Now person move on the along the track, then the degree of freedom is 1, because the word along is used. So whenever we see along the road, along the track, along the path, then the degree of freedom will remain 1. In the same way, the word used here is along the spring. Okay, so when we see along the anything, then the degree of freedom will remain 1. Another example, for example, y equals to 2x. Another one is y equals to x square, x square by 4 plus y square by 9 is equals to 1. These are the 3 different conditions, and if the particle is moving along these curves, then the degree of freedom for these curves will remain 1.